Welcome back again, Mr. Diamond again. We're going to take those velocity and the acceleration that we just looked at a second ago, and we're going to mess with the equations a little bit. Now, I'm not really going to walk you through the exact process of how we're going to rearrange the equations. We're not going to derive any of these because that's usually not super relevant for this class. But we're going to talk about some applications and some tweaks we can do that will be really useful. I really recommend that you take these equations and get like an index card or a piece of paper or something like that, and you keep it in the front of your notebook, and you just add these equations as we go so you can kind of make a reference sheet for it. You won't be allowed to use that on the test, but it's something that you will be allowed to like look back to, and you can have it all in one place because a lot of these equations will keep being useful throughout the whole year. So our first instance is a very obvious, very straightforward application of this, which is that for most problems, we aren't going to look at a time that's like 5 seconds and then 18 seconds, or 10 minutes and then 45 minutes. We're going to be looking at you start a timer and you end a timer. And if that's the case, we can pretty much get rid of the t naught, because t naught will just be 0, and anything minus 0 is the number. It's the same number. So we can simplify our acceleration is v minus v naught over t. That's a pretty easy simplification there. With a little bit of rearranging and some algebra, we can take this equation and we can, for example, find one where if we want to know what is a new velocity, if we know what speed did they start, what is their acceleration, and how long have they been accelerating, we can use that to find a velocity. We can find our new velocity after a given point of time. We can also rearrange to find a distance. So if we want to know, okay, here is the distance that we started at, or the position we started at, and then we're going to add that to whatever the velocity is, times however long we've been traveling at that velocity, will give us a new distance, or in this case, it could also be displacement, depends on exactly the wording of the question. We can also use the equation for calculating average velocity if we rearrange. Again, we're talking about this equation that we're rearranging. You can only do this if acceleration is constant. If your acceleration is constant, then the average velocity is going to just be whatever the middle point between v naught and your final velocity is. And that's because, let's say you start at 0, you get to 100 at a consistent acceleration. At the halfway point, you're 50, and then for every moment of the trip, you're going to be one step away from that. And it's kind of like they would cancel each other out. It's like if you had one number of 10 and then you average that with 10, 9, 11, 8, 12, 7, 13, 6, 14. All of those, because they're equal steps away from the middle value, will just average out to whatever the middle value is. So all we're doing here is saying, well, what is the average point or the middle point between these two digits? That's going to be your average speed. So if you started going 0, you ended going 10, your average speed over the course of that, if it's a constant acceleration, only if it's a constant acceleration, 0 and 10 would be 5. If it's 5 and 10, it would be, you take 15 divided by 2, 7.5. If it's 35 and 40, you would add them together, 75 divided by 2, what's that, 37.5? Whatever, that's the process that you do. Or did I do that math right? 35 and 40, 37.5. Yeah, math. I think I did that math correct. But again, only works if it's a constant acceleration. It's the only time that you can do it. Combining these last few equations together, we can get this really big equation that's also going to be super helpful. So if we know our initial position, our initial velocity, and how long we're going to be traveling, and we add that, so initial distance plus our initial speed times how long we traveled at that speed, plus 1/2 the acceleration times the time we took squared. Now this can be derived, and I'm not going to show you how to do it. Honestly, off the top of my head, I probably couldn't do it, just full disclosure. But you can derive this from the equations that we worked on earlier. Notice that in this case, this allows you to find any variable as long as you have all of them except one, and you don't need to know what the final velocity is. And it's not in here at all. V is not in this one at all. And then going to our other version of this equation that we can do, if you don't know time, and if you're at a constant acceleration, you can take and have v squared equals v naught squared plus 2a times distance, your final distance or your final point minus your initial point on the travel. So all of these equations, this is just me going through them. This is not going to be me working on examples. These are all the equations that you're going to want to be using for this chapter. So I'm going to go back here, and again, acceleration is equal to velocity minus initial velocity divided by time. That's assuming that time initially is 0. You can take a velocity and you find that from an initial velocity plus acceleration times time. Final displacement is equal to initial displacement or initial point plus the velocity, average velocity times time. Average velocity can be found if acceleration is constant by taking initial velocity and final velocity, dividing them by 2 after you add them together. You can figure out a final point, or how far was traveled, if you know the initial point, the initial velocity, time, and acceleration. And you can also find the final velocity if you know the initial velocity, the acceleration, and the displacement. Again, this one doesn't have time. In general, when you're solving these problems, and the way we're going to work through them, is you need to work on your strategy for them, because you're going to have the equations for the test. What I recommend you do is you list out what you have and you write what it is. So don't just write 3 meters per second, write V naught or V equals 3 meters per second. And you categorize all that information, you list it out, and then list out what you're looking for. And then since you have access to all these equations, you can just go back and look and see, well, which one has all the pieces or has the one I'm missing and I have enough to solve it. You don't always have to use the really big ones. Sometimes you can get away with the smaller ones. But if you look at what you have on your paper and look at what the equations you have and what they need, you should be able to just critical thinking-wise figure out what you're looking for. In general, you then also want to use algebra and rearrange and combine equations first. Then only once you have your equation completely in one, so that what you're looking for is solved for on one side, then you just plug everything into your calculator. And that feels kind of annoying, but it helps prevent rounding errors, because if you round every time you plug it into your calculator, you're just slowly going to add more and more errors to the problem that you're trying to solve. So this is our kind of general approach. That is all of our equations. That is technically the end of this chapter. We're just going to be working out basically different types of problems for this next week and this week and next week. Your test will probably not be next week, it probably won't be next week. It'll probably be the week after that. Don't quote me 100% on that, though. As you've probably realized, this is where everything's all up in the air this year, so who knows. I hope that makes sense for you guys. If you have any questions, please send me an email. I've made this joke in other classes. I don't think I've made it in this class, but if you want to try to send me a messenger pigeon or something like that, or Morse code, I doubt I'll receive it, but that seems like a cool way to try to communicate with me. Just let me know if you have questions, and I'll try to answer them. Hope you have a great rest of your day. This is Mr. Diamond signing off.